My human tripod.
And we can open it.
I have a little stable hand.
Always keep that checked. So then everything should be in there and you don't have to type it in. The names, variables, etc. For this first one, for the little table we're making, you don't have to change anything. You're going to go to Analyze, into Tables and Custom Tables. And for that question, you'll notice basically you want to find the percent acyanogenic and cyanogenic per population. So first, all we have is genotype. So we're going to drag genotype up here to the columns. There it goes. Source is the same thing as population. Those are all different populations. It is that simple. Push OK.
Cool.
Here's the data.
No drum roll.
We're going to copy special it. You want it as plain text so you can paste it into Excel. Okay, so we're going to copy it. Open up Excel. A new file. Here's our data. So let's just make this look a little bit neater. We don't need that column. This is the population. This is the total number of plants we did on Tuesday. It's 51. You probably want to record that somewhere, the total number of plants. You need that later for your calculations for your homework. I'm going to delete that, otherwise you don't need it. These are the 4 genotypes. So I'm just going to paste that over this. And delete these. We're getting there. We have a good looking, whoops. This is the empty, there we go. So what I've done, I've given you all the populations and then the 4 possible genotypes. So what we need to figure out is a percent acyanogenic and percent cyanogenic. And we also need the total number of plants per population. Let's do total number of plants first. That will be, big N represents the number in a population or the number of plants. So for formulas in Excel, you start that with the equals sign. And then we can just do sum. And then you put parentheses. You drag across that population. You close the parentheses and push enter. Okay, then there's that little box down here. When this little cross shows up, you can drag it down. Now we have the sum for all the populations. Okay, so then we can do the percent cyanogenic.
Do you mind? We're filming here.
And percent
Excuse me, love interest.
acyanogenic.
Get off the set.
So which one of these genotypes is going to give us a phenotype that is cyanogenic? B, C, D, or E? Or more than one?
B.
B, only B?
Yeah.
Okay, so then we can equals B. We're getting a percentage, so it's 2 divided by the sum of all of them in that population. Oops. We need another parentheses.
Times 100.
Yeah.
Another parentheses box.
I gotta push enter and then I'll zoom in and show you again.
There we go.
I'll zoom in, it won't let me until I push enter.
Relax. Take it easy. Just calm down.
I'll do it for this one. So for Alaska, equals, we have 0. This is the genotype for cyanogenic. To find the percentage, we have to take it out of the total number of plants. So we need the total, which you find by the sum. You take the sum for that population. And to convert it to percentage, we're going to need to multiply it by 100.
Whoa.
Make sure that one I had, though, dragged it slightly too far. There we go. But regardless, once you have 1, you can drag it down. Okay, you don't want all
Welcome
of
to the
these
show.
decimals.
New format.
Alright, better buckle up for this part. This is where it gets crazy.
This is the total number, so not through n. This is the total number of plants. You could have just selected the total number of plants too. That's just as easy. There's more than one way to do things. I can show you that for the acyanogenic if you want.
There's no such thing as a dumb question. Except for that question.
1 or 2 decimals. If you want to keep it, if you've done the total number of plants, you could also, which genotypes are acyanogenic first of all?
Everything
All the
besides the
other
first
ones.
two.
All the other ones?
First one.
So we're going to have to find the sum of those. And then we can just divide by the total number of plants here instead of a sum. There's always more than one way to do things. We're going to do
Always.
order of operations, though we need a parentheses. Okay? So obviously, if this one's 100% of your population cyanogenic, this is going to be 0. I always do them separately, though, to make sure I didn't accidentally punch in a number wrong. I'll always know that's like a double check. If they equal together 100, I know I've done it correctly. Sometimes shortcuts
I can't tap right now.
can end up with errors. So there we have all the data that we need, but we don't actually need these genotypes for our table. So I'm going to copy this into a new worksheet and then paste special just the values and the number formats and get rid of the equations. That will allow me to delete these and still maintain these numbers. Then the only thing you're going to have to do is add in the hardiness zone,
I don't know what just happened, but I got it on camera.
okay? And you'll get that from your lab manual. Those hardiness zone numbers are in your lab manual in the background information. So you just look at Alabama, you find it in your table in the background
Wait a
information,
quick
and
action
you type in
replay.
the hardiness zone.
That one.
Data slide by slide.
I have that, I think, somewhere. Get it?
Gotta get nice and wet first. Yeah, get it wet then finger. That's a trick.
Do you want to make our lab report during lab?
Written anything down yet?
Same.
What table for your lab?
This is really only for.
I read the title.
This is for a single table in one section.
Okay, so you can look at the
15 minutes in.
hardiness zones, and then go
15
ahead and
minutes,
sort
only
your
dabbed once.
data by hardiness zone so you
It's
can
a
start to
record.
see if there's a pattern.
Me and Mike and me and
Okay,
Sam really
looking
glad.
at it this
It's
way,
me,
you can't
him,
see any
Luke
pattern.
Stanley and Logan Shadaya. And literally all class is just dabbing.
Oops,
It's the whole
we're gonna have
time.
to select all the
So when I answer a
data.
question, we'll just.
We want to
like
sort by
different- just
hardiness
different moves
zone,
every
which
time.
is C.
What's your question?
And then you're going to want to give it some borders,
I can't check my
bottom,
text.
top.
Sucks, asshole.
These are just borders of demarcation, separates it from the rest of the paper. Where's the bottom? So that way when you copy and paste it into Word,
Get ready for this. Buckle up.
it looks
Oh,
nicely. I know what's going on up here.
Just dabbing.
I didn't know if you could see. Alright, so we can start to see a pattern already, kind of. It's not perfect, but you compare this to here. There's more cyanogenic plants overall at the bottom,
You're right, buddy.
the higher hardiness zones than the top, right? Yeah. Yeah, you just select your data.
I got that on camera. I'm
It
selling
will
this movie.
deselect them, even if
It's
you
gonna
do
be huge.
select them. Go to data, sort, and then C is hardiness zone. And then push OK.
Make the popcorn. This is me a great film.
So that's the first table. So that's what you'll need to do for your first table and for your homework. For the clustered bar chart, let's go on to that.
Oh man.
Did you say all these directions are on the slides too?
Yes, and like for example, these slides are what's on Moodle. So you've already organized the data. So, but what we need to do ultimately, our question is not as how does every single population vary with hardiness zone, but our
Stop
question
recording. You're
is
shaking
what
so much. Jesus.
does
Parkinson's.
what relationship are we looking for? I mean, does every single population have cyanogenesis or acyanogenesis? What two things are we trying to relate? Hardiness zone is cyanide production, right? So some of these you'll notice back, if we go back to our Word file, look at how many we have in zone 6, how many we have in zone 7,
Okay.
how many we have in zone 8.
Mhm.
We're going to need to find the average of those and just have one number for zone 6. One number for zone 7.
That was the
one number
highlight
for
of my
zone
day.
8.
Stopping the entire class. when I
Okay,
know
so
you
to do that, we can just find the means and the
With what?
standard errors.
Just a loud dab.
I'm going to
Everyone stops.
show that next, and then we'll talk about it.
Mhm.
Alright. Analyze, compare means.
Colin, check this out. Colin, look at this. I just gotta flip them off.
What's going to be the independent? What's going to be the dependent? How are we going to. You guys remember?
Zone independent and then genotype dependent.
Yep, zone independent, genotype dependent. Actually, well, this will work. No, it won't.
Oh. Dope.
Yeah, it won't. This is good.
Ricky, you gotta stop shaking so much, buddy.
What did I do?
This is the worst video I've ever seen in my life. Rick, cheer up, buddy. It's okay.
Alright, I forgot I had to paste in the numbers.
Hey, stop ruining the
Sorry
video.
guys, we're going to paste in the numbers of the table we
This
just
is
made.
13 minutes now.
In fact, we should save this so we don't have to do it all over again. So this is Clover data discussion. It is on percent. So we're going to need to open up a new SPSS file
So we meeting up to watch this game film after?
with new data.
What's the highlights?
So you're going to want your data to be entered now with acyanogen and cyanogenic. So we have to make that table anyway just to be able to go to the next part of the analysis. So that's the table we just made. We just copy and paste it into SPSS now. That's all. Okay, now we can do the same thing that I was trying to do. Analyze means.
Freaking weirdo.
Hardiness zone is the independent, as we said. Now the dependent is acyanogenic and cyanogenic.
Okay. So you hate Jesus. Let's go.
We want to find the mean and standard error. So we have mean and standard error of the mean. That's just by going here to this little options button. Okay, and selecting what you want. That looks better. Here we are. Here are the hardiness zones, the means, the standard errors of the means, and we have the percent acyanogenic and cyanogenic. Now you'll notice a lot of little periods or decimals. Periods we'll call them. That means there's zero standard error for those. That's for one of two reasons. What are we taking the average of? Populations. What if we only have one population?
No standard
There's
error.
no standard error. That's one way you can get a decimal. The other way would be is if they have exactly the same percentages. They vary in the exact same way. They are both 50% cyanogenic and both 50% acyanogen. There's no variation. There's no standard error.
That's what the kids these days call them.
Okay, so you can copy special again as plain text. Or you could do this in SPSS. I don't care how you do it. You just got to make a clustered bar chart.
No.
So here's the hard
You lost your privilege,
zone.
Colin.
I think I'll pay you back.
No, it's my phone now.
And then the standard
Buddy.
error, we're going to want to make those,
Sabotaging.
oops.
There's a lot of shaking.
Yeah. Works like Michael J. Fox over here.
Standard error, the mean. This will be for acyanogenic. And this one will be for
What I do?
You dab. That was
Yeah.
cyanogenic.
You gotta dab loud and proud, man.
Okay, so
What's
you
the
can
point?
just cut and copy these then. They have to be in this order to make the graph. That's why I'm doing this, or the graphs cannot be made. So what I'm doing is taking the standard error for population 5 and putting it right next